Hi everybody, how's it going? Today's bell work assignment is going to focus on pyramids because that's what your lesson was from Thursday last week. And then after you complete this bell work reviewing pyramids, the main lesson for today will actually be regarding cylinders. So let's get going on some bell work problems with pyramids though. So when you watch every one of these videos and lessons, hopefully you are copying down the formulas onto your formula sheet, because when we get to the actual Unit 10 test, you'll want to have all those formulas all in one spot together. So hopefully you are keeping up with that part. All right, so here we have on the screen a little reminder for you about the pyramid formulas for total surface area and lateral area. Remember that total surface area is the sum of all of the areas of all the faces of the solid, including the bottom, including the base. The lateral area does not include the base at all. So in this particular pyramid, the lateral area would not include this bottom square. So really, if you calculate surface area and lateral area, you are expecting that the lateral area is going to be less than the total surface area. Okay, so let's just get right to it. When you look at these formulas, do you know what the variables mean? It's not going to help you out much to have a formula if you don't know what should be substituted in place of those variables. So capital B right here, capital B always means area of the base, okay? And so on this particular pyramid, we see that the base is this square. So what would be the area of that base? What do you guys think? Well, it's a square. And a square is a type of rectangle. So area of any kind of rectangle, we just do length times width. So we want the area of this square. It's going to be 8 times 8. So that means that our capital B is going to be 64 square inches. That's the area of that square base. Okay, let's go to the next variable. The next variable we see here is P. P is the perimeter of the base. So you want to add up the lengths of all the sides of that base. So in this case, it would be 8 plus 8 plus 8 plus 8. Or you can accomplish the same thing with just calculating 4 times 8. So our P value is going to equal 32 inches. That's the perimeter around the base. What do you have next? Next you have L, and sometimes you'll see L written as a cursive L, and sometimes like in the videos from last week you see it written as a capital L, but L means slant height. It's not the height that goes straight up to the top point, it's a slanted height. It's this height that goes up on a slant from the midpoint of the bottom of one of these triangles on a slant all the way up to the top of that pyramid. So really the slant height is like if that triangle face were laid flat, it would be like the height of the triangle. But as far as the pyramid goes, we call it the slanted height or slant height of the pyramid. All right, you guys, you have everything that you need now. So let's calculate it. Total surface area for the entire pyramid would be capital B plus half times perimeter times slant height. What was the slant height? The slant height was given to us labeled as 10. Okay, so calculate that. You could do that all at once. If you want to calculate that entire expression into your calculator at once, you can. Or if you like to calculate, as far as order of operations go, do all the multiplication before you do the addition. So half times 32 times 10. You could do that portion of it first if you'd want. Okay, so 64 plus 160, what are you guys getting? Total surface area, 224. And what are your units? Because it's a type of area, squared units always, square inches. All right, and then when you look a little further down, it's asking you for what's just the lateral area. The lateral area will not include the base. So all we're doing is the part of the formula that's after the plus. This half times P times L will calculate just your lateral area for you. So half times P times L is all we need. And I could rewrite that, but if you guys look, we had it actually right here. Half times 32 times 10 which was this portion right here. So our answer for lateral area for this pyramid is 160 square inches. How'd you guys do on that? Anything you weren't sure about? If you have any questions, please email me or join our Google Meet. Okay, let's slide down and see another problem. And then the next problem, it will ask you for volume. We want to review that. But also, it's a problem where you have to do a little extra calculating on the side. Let's take a look. Move this out of the way. All right, you guys. Take a look at this picture. Ooh, I'm giving you a little bit too much here. Let me fix that. All right, so let's take a look at this pyramid here. This is another square pyramid. The base is a square. Remember that pyramids don't have to have squares as a base. A lot of the examples that we're giving you guys do have a square base, but they don't have to. They could have any polygon base. It could have a triangular base, a hexagon base, a pentagon base. So the shape of the base can change, but you're always going to have those lateral faces being triangles on any pyramid. So let's get to it. Surface area. You have the formula up at the top. We just were looking at that. Do you remember what that formula was? It was total surface area for a pyramid will be calculated with the formula B plus half times P times L. Okay. So do you guys have all the information you need for those? Let's start going one at a time. Okay, so we need the base. Remember, B stands for the area of the base. So we need the area of the square. Can you guys calculate that? Yes, you can. Yes, you can. Okay, so B, area of the base, it's a 10 by 10 square, length times width. So the base, or area of the base, is 100 square inches. Okay, what else do we need? We need P, that's the perimeter around the base. So we need to add up this plus this plus this plus this. And we could do that. Remember, it's a square, so all those sides are the same. 10 plus 10 plus 10 plus 10 to give you 40. Or you can do 4 times 10. Same thing. And your perimeter then will be 40 inches. Okay, we're kind of moving right along here. What's next? Next is L, slant height. Do we have the slant height? No, we do not have the slant height. We have H. We have just the regular height of the pyramid, but that's not the same as slant height. L means slant height. So I would have to draw in a slant height. Oops, sorry, that's not the straightest slant height. But the slant height comes up through the middle of one of those triangles. And then what we do, you remember this from the Ed Puzzle video, connect the bottom of the segment representing height to the bottom of the segment representing slant height. Okay, this is slant height right here. Do I know the length of this segment? I do, because it's exactly half across the length of the square. So if it was 10 inches all the way across, this segment right here will be 5 inches across. And what do you guys have? You know it. It's a right triangle, and you know 2 side lengths. You're missing a third, and that is always when we use Pythagorean theorem. A squared plus b squared equals c squared, or leg squared plus leg squared equals hypotenuse squared. Let's set that up. Leg squared plus leg squared equals hypotenuse squared. Okay, let's evaluate that left side. That's going to give us 25 plus 144, or 169. And that's still what L squared is equal to. Take the square root now to solve for L. The square root of 169 is 13. So we just figured out that this slant height that we need is actually 13 inches long. So right here would go with 13. Let's put it all together and let's calculate our surface area for this pyramid. So surface area equals our base area of 100 plus half times the perimeter around that base, which was 40, times the slant height of the pyramid, which we just figured out was 13. Okay, you can calculate this first if you want, half times 40 times 13. Or in your calculator, you can just calculate this all at once. It's up to you. If you did half times 40 times 13, it would be okay for you to add on the 260 to the 100. 360 square inches. Good job, you guys. 360 square inches for the total surface area of the pyramid, which does include that square base. All right, volume is next. Do you remember what the formula is for volume of a pyramid from the Ed Puzzle video you guys watched? Or even just looking at your formula sheet that you've been putting together? Okay, good job. Volume for a pyramid will be calculated with 1/3 times the area of the base times the height. That's height, H height, not lateral, not slant height, but just the normal height. Do we have everything we need? Let's see. Do we have the capital B or the area of the base? Yes, we do. 100. We already figured that out. Do I have, I need a different color here. I'll use purple. Do we have H, the height of the pyramid? We do have that. That's what this was that we started off with. That's the height from the middle of the base straight up to the top of the pyramid. That is our height. Okay, nice. So there's really nothing new to calculate here, you guys. All you have to do is substitute in those values into our formula. 1/3 times 100 times 12. What do you do when you multiply that out? 1/3 times 100 times 12? You are right, you guys. You get 400. And it's volume. So what kind of units do you use? You guys are so smart. You're right. It was cubic units because it is volume. Okay, there's a lot of writing over there. Let me just maybe get a different highlighter color. So your final answers for this one, surface area of the pyramid was 360 square inches, and volume for this pyramid was 400 cubic inches. I hope that helped you guys out with understanding formulas for pyramids and how sometimes you might have to use Pythagorean theorem to help you find either a missing height or slant height. Hope you're all doing well. Like I said, email me if you have questions. I miss you all. Bye.